Okay, 2.3 linear equations. So first order differential equation of the form a1 x dy over dx plus a0 xy equals to g of x said to be a linear equation. So this is basically y prime, this is y, and there's no y on the right hand side. So that is the linear equation. And we also can say differential equation is the homogeneous if we have this g of x equals to 0. Okay, so right hand side is 0, we call homogeneous equation. If it's not, then non-homogeneous equation. So the standard form of linear equation looks like this. What happened here is we don't have the coefficient in front of dy over dx. I said don't have, but basically we have as a 1. So if we say a1 over x equals to 1, if it's not 1, then we need to divide every single term by a1 of x. That's what it says. To solve this linear order differential equation, step number 1, you need to put it into standard form, and then you need to find integrating factor, and then multiply both sides by integrating factor, and step number 4, write into form and integrate both sides of this equation. So I give you a couple of minutes. Okay, I want you to write this down. Step number 1 as this standard form. Step number 2, integrating factor. How? Using this equation, e to the integral p of x dx. Step number 3, multiply both sides with the integrating factor. And step number 4, with this form. And step number 5, integrate both sides and solve. So for our class, I'm going to say using integrating factor, solve that first order differential equation. Then you need to go through these 5 steps. The first order differential equation, the easiest way to solve the first differential equation is to using separable technique. We have a dy over dx plus 2xy equals to x cubed. Dy over dx equals to x cubed minus 2xy. Now you multiply both sides by dx. Dy equals x cubed minus 2xy times dx. If you divide both sides by y, 1 over y dy equals x cubed over y minus 2x dx. So it is not separable. So we cannot use the separable technique in here. Find the standard form. So we need to write dy over dx plus 2xy equals x cubed. Dy over dx and the y. Those are the key terms that you need to keep an eye on it. And then we need to find the integrating factor. When you find the integrating factor, we need to use p of x. That's why I use the parenthesis right here. So integrating factor, e to the integral 2x dx. This is 2x. That's the p of x. That is e to the, when you take the integral of 2x, it's going to be x squared. Now we need to multiply this integrating factor for both sides. dy over dx times e to the x squared plus 2x times y times e to the x squared equals x cubed times e to the x squared. Up to this point, everything is very straightforward. Now, here's magic trick. Watch this. This whole thing on the left-hand side is gonna be d over dx y times e to the x squared. And then right-hand side is this. Whoa, wait a minute. What just happened? How can we say the first term dy over dx times e to the x squared? That's basically is in here. And then what happened to the second term? It's not really straightforward going from here to here. However, if we do this from here, d over dx of these two terms, okay, if you apply the product rule, so when we have y equals a times b, they are both in, let's say, x terms, then what we do, a prime b plus a b prime, first derivative of second plus first second derivative. Do you remember this? It's a product rule. So if you apply the product rule from here, then first derivative dy over dx times y times the second one, which is e to the x squared, plus first y, and then second derivative, d over dx, e to the x squared. Now the first term is d over dx times y, e to the x squared plus y times. When we differentiate this, it's going to be e to the x squared times we need to differentiate this whole term. So it's inside, which is 2x. Then if you compare this whole thing with this guy, now they are the same. You copy down from there. This is just, again, one technique to solve the differential equation. And then we take the integral for both sides. Integral d over dx is going to go away. And then we have y times e to the x squared equals integral x cubed e to the x squared dx. Now on the right hand side, we have x cubed times e to the x squared. So we cannot take the integral as it is. So we need to do some substitution technique. Let's say we're going to let x squared as a p. If you differentiate both sides, then we have a 2x dx equals dp. We have a x dx equals 1 over 2 dp. Now we're going to rewrite this as integral p x squared times x. So p is x squared times x give us this x cubed times e to the p. Forgot to write it. Dx equals to what? 1 over 2 times 1 over x times dp. 1 over 2 times 1 over x times dp. X cancel out. That equals 1 over 2 integral p dot e to the p times dp. Now we can do integration by part. There's a u equals to p, dv equals to e to the p dp. So we have v equals to ep, du equals to dp. That is 1 over 2 times uv p e to the p minus integral v du. Now, if you put the whole equation in terms of x, then it's going to be 1 over 2 p, we said x squared e to the x squared minus e to the x squared plus c. If you multiply everywhere by e to the negative x squared,
we have the y equals 1 over 2 x squared times e to the x squared times e to the negative x squared minus 1 over 2 e to the x squared times e to the negative x squared plus c times e to the negative x squared. Then y equals 1 over 2 x squared minus 1 over 2 plus c e to the negative x squared.
let's do one more. X times dy over dx plus 2y equals to 3. It's not standard form because of this guy. So for standard form, we have to write it dy over dx plus 2 over x times y equals 3 over x. And this is p of x. Now it is standard form and it is linear equation. Find the integrating factor. E to the integral p of x 2 over x dx, that is e to the 2 ln x, and that is e to the ln x squared, and that is x squared. Now we're going to multiply this integrating factor for everywhere. Then we have dy over dx times x squared plus 2 over x times y times x squared equals 3 over x times x squared. So now Dr. Kim's magic, the left-hand side, that's the complicated equation, became d over dx y times x squared. Ta-da! I'm gonna do one more time. If we actually apply this d over dx to these two terms using product rule, first derivative second plus first second derivative, And that is d over dx y times x squared plus y. If you derivative of 2x squared, that is 2x, and which is exactly same as this guy. Now we need to take the integral for both sides, and then we have y times x squared equals integral of 3x. We have a 3 times 1 over 2x squared plus c. And this is implicit solution, and if you are asked to find the explicit solution, y equals 3 over 2 times x squared times x negative 2 plus c times x negative 2. Y equals 3 over 2 plus c over x squared, or c times x to the negative 2. Last one for the linear equation. Cosine x times dy over dx plus sine x times y equals to 1. And this is not the standard form because of this cosine x in front of dy over dx. So what do? Divide. Dy over dx plus sine x over cosine x times y equals 1 over cosine x. Any of you printed up the equation sheets that I gave you? Good. So what's the sine over cosine? Tangent. Dy over dx plus tangent y equals 1 over cosine secant. So now it is a standard form. Now we need to find the integrating factor. E to the integral p tangent x dx. Integral tangent x dx from the cheat sheet I have here e to the negative ln absolute value of cosine x. In the cheat sheet plus c, and we're going to have only one plus c at the end. So we don't have to put plus c here. Equal e to the ln cosine x power of negative 1. And e and ln cancel out. That is 1 over cosine x. And 1 over cosine x is the secant x. So instead of keep writing that absolute value, we're going to keep cosine x is greater than 0. So now we need to multiply integrating factor to everywhere. Then we have
dy over dx times secant x plus tangent x times y times equals secant x secant square x. And Dr. Kim's magic, again, y times secant x for the left hand side, and the right hand side secant square x.
Now we take the integral y times secant x equals integral secant x. In the cheat sheet section of the integration formulas, 1, 2, 3, 4th line, it says that equals to tangent x plus c. And this is implicit solution, and I ask you to find the explicit solution. Then you need to do isolate y. Y equals tangent x times 1 over secant x plus c times 1 over secant x. Make it a little bit nicer. Tangent, sine over cosine. Secant is 1 over cosine. So 1 over secant, which is cosine, plus c cosine. So your final answer is going to be sine x plus c times cosine x. And don't forget, we have a cosine x has to be greater than 0.